Hello students, and welcome to section 4-3 through 4-5 review. We're going to start off in section 4-3 and discuss congruent triangles. We will be taking a look at quite a bit of review material that also entails some theorem analysis, some definition and postulate analysis, which also may lead to us looking at proofs. Definition: two triangles are congruent if and only if there is a correspondence between the vertices, so that corresponding angles are congruent and corresponding sides are congruent. Please notice this is an answer key that I am pulling from using another colleague's work here, which is just fine. We use each other's work. This is noting again here that congruent triangles, if and only if corresponding parts congruent. Okay, CPC-TC, if you recall, stands for corresponding parts of congruent triangles are congruent. So for the very first depiction here, we see the side in blue marked here as congruent to the other side in blue on the other triangle, purple and purple, and then green and green. Nicely color-coded. Order matters. In terms of AB being congruent to what? Well, I would hope you would all agree that it's congruent to RT. BC in order should be congruent to TS. And lastly, AC is congruent to RS. I'm going to move that over here. Okay. AB, or pardon, A, the angle, corresponds to what angle, but also vertex, technically, I guess. They're not saying angle per se. Although we also know that angle A is congruent to angle R. Technically, we're talking about the actual vertex. So A corresponds to R, B corresponds to T. Look at the picture again, and then C, of course, to S. Please make a note of that. So our conclusion should end up looking something like what? Triangle ABC is congruent to triangle RTS. Okay, so A and R, B and T, C and S are color-coded and correspond as we saw in the last kind of portion. Therefore, your triangles must be represented as congruent in that order. Since the definition is a biconditional, we know triangles are congruent. Then we can conclude their parts are congruent. However, in order to use the definition to show triangles are congruent, we must prove all 6 pairs of corresponding parts are congruent. So for this next problem, it's given. It looks like a proof, but it's actually not. They're just giving you information. You're not trying to prove anything. You're just trying to find values here. Triangle PQM, which is drawn for you here, is congruent to triangle HJL. Notice the color coding again. All right, I do like that, and I've done that with you guys as well. Maybe a little bit prettier than my work, of course, but if you take a look, you can identify what PQ is 15 in the picture, congruent to certainly HJ, marking them accordingly, and the letters are in a very specific order, so PQ congruent to HJ. So 15, of course, as you see. Angle M is 37 degrees. And of course, so is angle L, as these are congruent. And then last but not least, angle J is 58, which of course is congruent to, this is 58, which is congruent to this angle, pardon, Q, 58 and 58. You can do the math of which when you add 3 angles, they equal 180 of a triangle. Subtract from 180 and you get 85 to be the resulting remaining angle, P and H on both triangles. So we can kind of see here, of course, HJ is already deciphered as 15. Angle L is 37 degrees, like we said. 58 degrees now for angle Q. And last but not least, 85 degrees for angle H. Okay. There is a nice kind of breakdown of which you see corresponding parts congruent. PQ is congruent to HJ. QM is congruent to JL, and PM is congruent to HL. Next page. The third angle theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. We are not going to formally do the full proof here. I just wanted you all to see that angle A, given it being congruent to angle R, so it's marked accordingly, and angle B congruent to angle S, also marked accordingly. If you know this is 100, that must be 100. If you know this is 50, that must be 50. So according to the third angle theorem, both triangles, although one is smaller than the other, they're not congruent. Please keep that in mind. Even though the angles are correspondingly congruent, the two angles that remain, yes, are 30 degrees each, but they are not congruent triangles. Okay, you can do 180 minus 150 here and get 30, 180 minus 150 there, and of course also get 30. Be very careful. There is no such thing as angle, angle, angle. Angle, angle, angle does not apply at all with regards to congruent triangles, so be careful with that. Moving on. So, and again, that's not a proof per se, it's just a justification that yes, those two angles must be congruent. We do the math. Congruence of triangles is reflexive, symmetric, and transitive. Although we have discussed the transitive property and the reflexive property, we haven't really yet discussed the symmetric property in context. And the proof, which again is more kind of roughed out here, where we're just going to describe the statements. Since congruence of the segments and angles, which are the parts of the triangles, is reflexive, symmetric, and transitive, it is an immediate conclusion that the congruence of the triangles would also follow the same pattern. For example, the reflexive property states, for this particular triangle ABC, if triangle ABC, then triangle ABC is congruent, well, to itself. Okay, I don't think that's a big surprise. We've done the reflexive property before in various ways. For example, like saying AB is congruent to AB, if let's say it's two triangles that share a side AB. This is just a very similar way to express those two triangles congruent. One triangle congruent to itself, technically. So here is another depiction of, though, now two congruent triangles. So if you were to flip the triangle letters, or triangles themselves, leave the letters as is, but the triangles are flipped in such a way where, symmetrically speaking, right, you can flip and it's still true that triangle RST is congruent to triangle ABC. Just flipping the triangles. The transitive property, if ABC is congruent to RST, triangle RST, and triangle RST is congruent to triangle MPQ. Remember, these two are the same, so you're linking them in such a way now where the first and the last triangle have to be congruent. And there you go. A triangle ABC is in fact congruent to triangle MPQ. Just as a side note, yes, yet again, if you're using the symmetric property correctly in the right order, particularly of side distinction, we've got AB congruent to RS, which is denoted here. We've got BC congruent to ST, denoted here. And then lastly, AC must be congruent to RT in order. So that would be a nice way to kind of describe those two triangles being congruent. I would argue this would be a side-side-side reason. The symmetric property, again, only allows you to flip the statement, but technically if you're going to prove that they're congruent, side-side-side would be a nice way to do that. Okay, it'd be one of many possible ways, but based on what we're writing, maybe that would be, the point of that particular question if one existed. Okay, so that concludes section 4.3. I'm going to go ahead and continue. Well, there is homework and the answers are there as well. I'm going to actually continue with 4.4 and 4.5, and I might bounce back to the homework or even the answers just to prove a little bit more here, but we'll see. We'll see how far we can get with this. So the next two sections, 4.4 and 4.5, the beginning, as you can see, is a description of included angles and sides. Angle C and angle B have an included side of BC. It says it here. In triangle ABC, BC is the included side, or is included between the two angles. The endpoints of the segments are the vertices of the angles. It is also true that angle A is included between AB and AC. Now you don't see the angle marked nor the sides, but it would be true that angle A is between AC and AB. We've discussed included angles and sides before. This is a good review. And the next part here, it does say that in triangle RST, angle R is the included angle. Here's the picture of that side and that side. I would argue that's pretty obvious. So RT and RS. So there it is, RT and RS. Angle R is in between. And then in this triangle, MNO, ON is the included side of what two angles? Well, look at the picture, it's marked accordingly. So angle O, okay, and angle N. All right, see if I can move both of these here. All right, so that's how that's going to play out. And we do know that, again, this angle and that angle are the angles in the question of which this included side is in between the two. Okay, moving on. Congruence postulates for triangles. We've discussed side, side, side before. I do want to just speak to how the parts AC is congruent to RT, as you see down below. AB is congruent to RS, and so on and so forth. Okay, I thought that I had more to show you here, at least to uncover. I think I'll do that here. All right, maybe I won't. Okay, I think that's just the underline there. That's right. Anyway, so side, side, side is a way to prove triangles congruent, and these three sides, as you can see in that respective order, those two are in order, those two are in order, as are those two. The two triangles in the right order, again, ABC, ABC is congruent to RST. Side angle, side is a matter of you using the included angle, given that AB is congruent to RS, which they say here. Angle B is congruent to angle S, and then lastly, BC is congruent to ST. So side, angle, side. The angle, of course, again, being included between the two sides. This is another proof, but this time I think, yeah, we are going to take a look at it in full. So we've got a triangle APD, and we also have CPB. In the picture, well, based on what we have in the picture, and of course also in the given, BD bisects, so it divides in half segment AC. So AS must, or AP, pardon, AP must be congruent to CP. AC bisects BD. Okay, so because that's the case, we know that this segment here, DP, must be congruent to BP. We also have a designation of angles congruent here and here. APD is congruent to CPB because vertical angles are congruent. All these things should be marked up before you even begin the proof. And I would argue you already also know that you are going to use side angle side as your final reason to prove that the two triangles are congruent. This particular proof looks to be more of like a flow proof. The given, you don't have to write it out. Just write given. Again, two column proofs using the statement and the reason are what we've primarily done. But flow proofs are another example where we can kind of truncate our work a little bit. We're letting you guys do that, if in fact we do flow proofs, or you know, if you're asked to do one. The second step here is to just denote that the because of the given, P is the midpoint of AC, and BD is also, because it's being bisected, also it happens to be a midpoint, but of the other segment. So there is a midpoint of that segment, AC, but also of that segment, BD. We can argue then that AP is congruent. Right here, AP is congruent to CP, but also PD is congruent to PB. And that is by virtue of the midpoint implying two congruent segments. Almost done. Step 4, angle APD is congruent to angle CPB by virtue of vertical angles congruent. Notice we're just kind of off to the side noting the reason. And then last but not least, as we've suspected, triangle APD is congruent to triangle CPB in that order by side angle side. This does conclude the notes for today based on my time, but I do ask that you go through and finish up the rest of the notes on your own and follow through given the answer keys, of course, and do your homework as well.